704,106, 704,106. Consider the power series. What we have to consider? Just consider about this power series. Or what is the power series? Sum of n square by n plus 1 whole to n square into x to the power n varies from 1 to infinity with coefficient in real numbers. Coefficients, this coefficient is from real number. Which of the following statement is true? You have to search which one is true. The radius of convergence of this series is 1 by. If I talk about radius of convergence, what is this? 1 by e. The radius of convergence. The radius of convergence of the series is 1 by. If I talk about radius of convergence of the series, that is 1 by. The series converges at x equal to 5. What happened? At x equal to 5, the series is convergent. Another one is at x equal to 3, series is convergent. For all x with norm of x less than 1 by 2, the series is convergent. So we have to check which one of them, which of the following statement is true. So solution is that the power series is given by, how power series is given by? Sum of, this is the power series given by sum n from 1 to infinity n to the power n square by n plus 1 whole n square x to the power n. Let the general term, if I talk about general term of the series be an x to the power n, and an is what? N to the power n square by n plus 1 to the power n square. The radius of convergence, if I talk about radius of convergence r, can be found using the root test. Why we are using root test? Why not ratio test? Because there in root test we know that power 1 by n is coming, and here also n to the power n square is there, power 1 n is there. So that we can cancel. That's why here both in downside in numerator as well as in denominator n is there. That's why we are taking root test. Otherwise we can take ratio test also, which state that what it state, it is root test radius of convergence for radius of convergence r. 1 by r is what? Limit supremum of n tends to infinity norm of n to the power 1 by. This is the formula for radius of convergence, to find radius of convergence, and with the help of that you can find convergence. So let's conclude. Firstly we will calculate what we will calculate, mod of a to the power n to the power 1 by n. So what is an to the power 1 by n? An is this mod of this and power 1 by n. An already we have taken this value, so we will put here and power 1 by n. Since n is positive, we can remove the absolute value. Since n is positive, we can remove the absolute value. So in place of absolute value, we will write just bracket to the power 1 by n. And so 1 by n will multiply here. So n to the power n square by n, and n plus 1 to the power n square by n. So n will be cancelled. So n to the power n by n plus 1 to the power n. So this is the thing will come. n by n plus 1 to the power n is equal to what? N plus 1 minus 1. We can write here. In place here we can add 1 and subtract 1. We can do. Then after calculation you will get same thing. What we can do? Just n plus 1 put with this n plus 1. So it will come 1 minus. If you put with this, then it will come minus 1 by n plus 1. And whole to the power n is there, n is there. Now we need to find the limit as n tends to infinity. What we have to do? We have to find limit as n tends to infinity. Why? This formula is saying that limit supremum n tends to infinity. Just limit n tends to infinity, and whatever supremum value will become, that is the 1 by r. So we will take what? We will take limit n tends to infinity. So limit n tends to infinity 1 minus 1 by n plus 1 whole to the power n. This limit n tends to infinity this way here. The limit is a standard limit form. If I talk about this limit, this is the standard limit form. Okay. This limit is a standard limit form. Okay. So we know that limit k tends to infinity 1 plus a by k all to the power bk is equal to e to the power ab. If this kind of form is there, like limit k tends to infinity and a by k bk is there, here kk. So this term and this term will multiply e to the power multiplication of this term. So kk cancel, ab will come. So firstly we have to change this form in this form, then we can solve. So what they are taking, let here this whatever changing here, same thing is here and same thing is here. So we are taking k equal to n plus 1. So in place of n plus 1, we are taking k. So since n is tends to infinity, so n plus 1 will also tends to infinity plus 1, that is same as infinity. So k tends to infinity. And 1 minus, and in place of n value will come k minus 1. So here k minus 1. As n tends to infinity, k will also tends to infinity. Okay. So this is the value. Now what we will say, in multiplication power is going to or so we will write in form of multiplication. What is there? Multiplication. Multiplication form we will write. So multiplication of first term and same thing in multiplication is second term. How what we did? We have taken first at k power and another time minus 1 power here. Okay. If you multiply this, firstly we will solve for this one, then we will solve for this. We know that limit k tends to infinity of this. What we know, this is e to the power minus 1. How? This formula. This and this multiplication e to the power. E to the power multiplication and this will cancel minus 1, minus 1. So it will come 1 by it here. Now we will calculate for this one. So limit k tends to infinity 1 minus 1 by k to the power minus 1. If you put directly k tends to infinity 1 by infinity is 0. So 1 to the power minus 1 is 1 by 1. 1 minus 0 to the power minus 1, and it will come 1 by 1, and that is 1. So here it will come 1. So first term can 1 by e, and this one is 1. So now if I talk about limit n tends to infinity a n power 1 by n is 1 by e into 1, and that is same as 1 by e. Therefore the radius of convergence r by 1 by r is 1 by e, which means the radius of convergence r is what? Nothing but e. So radius of convergence can e. So now we will verify the statement. First statement is saying that radius of convergence is 1 by l. The radius of convergence of this series is 1 by e. So this is false because radius of convergence came how much? E came. So statement 1 is false. Statement 1 is false. And we also know r value is e equal to 2.718. And if I talk about second option, statement 2, this is also false because norm of x is 5 and that is more than e. If it is more than e, that is divergent, the series diverges at x equal to 5. So when it will converge? When it is less than whatever value of x that is less than e, then it will converge, otherwise it will diverge. So statement 2 is also false. If I talk, since r is e 2.718 and more norm of x is equal to 3, and that is also more than e 2.718. So it is more than e, and that's why the series also diverge at x equal to 3. So statement 3 is also false. So statement 2 is also false, 3 is also false, first is also false. Now we will move to last option. Since r is equal to 2, r equal to e 2.718, the series converges for all x such that norm of x, mod of x less than e. For what value of x it is converging? That mod of x value should be less than e. And since here it is given 1 by 2, 1 by 2, and that is less than e, any x with norm of x, mod of x is less than 1 by 2 will satisfy mod of x less than e, and therefore the series converges for all x. It will converge for all x with mod of x is less than 1 by 2. The statement 4 is false, true. That's why what will happen? Statement 4 is true. Statement 4 is true from here. So if I move to next, the statement is true because the radius of convergence r is, statement is true. Why? Because the radius of convergence r is equal to e, the power series converges. When it will converge, if power mod of x value is less than r, and r is e, means mod of x is less than e, then it will converge. And here mod of x is less than 2, 1 by 2 is less than e for any x such that norm mod of x is less than 1 by 2 will also satisfy mod of x is less than e, and thus the series will converge. So final answer is option 4. Option 4 is the final answer. Fourth one is the final answer. That's it.